We're going to take a look at something here now called the reflected load in a transformer circuit. We're going to see that it kind of equates to something that we saw with a Thevenin's and a Norton's relationship. And we're going to reduce the output or the load across the secondary with the secondary in terms of its resistance. So you can see here the actual load and the reflected load being shown. The load, R sub L, is the secondary of a transformer as reflected into the primary by transformer action. The load appears to the source in the primary to be a resistive R primary with a value determined by the turns ratio and the actual value of the load resistance. And we're going to call this resistance the reflected resistance. You can see here a quick synopsis of how that value down here, R primary 1 over N squared R sub L, is derived. Take a look at that and you can prove it to yourself. So the value that we actually need, we're going to use in some examples, is this R primary is equal to 1 over N squared RL. This is our reflected load. So the resistance reflected into the primary circuit is the square of the reciprocal of the turns ratio times the load resistance. In this example, we've got an example here with a 1-to-4 transformer with a load of 100 ohms. We want to find what the reflected resistance is by the source. Again, we just rely on the relationship that we just saw that was developed. 1 over 4 squared R sub L, or 100 ohms, gives us 6.25 ohms. So you can see by the diagram on the bottom, this is actually what the primary sees in terms of the resistance reflected from the secondary. In another example, we're going to use a turns ratio of 0.25. So we put 0.25 in the denominator here, 1 over N squared, again times 100 ohms, and the value then comes out to 1.6K or 1600 ohms of resistance. This result then illustrates the difference that the turns ratio makes in calculating the reflected load. In the next section, we're going to look at something that's very important. Any of you that are audiophiles that understand that you want all of the power from your amplifier being delivered to your speakers. Impedance matching is the way that you verify you're not getting any cutoff or distortion. So in the next section, we're going to take a look at an application of a transformer in impedance matching the load impedance from a source. So we're going to come right back to our impedance relationship. You'll recall it is a relationship where we deal with imaginary numbers, our J factors. So we're going to revisit those values for impedance.